Hello everyone. Today we have a chemistry theoretical yield problem, which we're given an equation of aluminum sulfite and 6 sodium hydroxide, which turns to 3 sodium sulfite and 2 aluminum hydroxide. The problem does give you the mass of aluminum sulfite and the mass of the sodium hydroxide, and it's asking you what will the resulting theoretical or maximum mass of sodium sulfite that can be formed. So the first step to this problem is to make sure that the equation is balanced, and you can take my word for it. I did check it, and it does appear to be balanced, but it is good practice for you to check it for every type of problem you have like this, is to always make sure it's balanced. Sometimes the problem will tell you that it's balanced. Me personally, I still do check it if I have enough time. The second step would be to determine the molar mass of each of the molecules. And the way to do that is you can easily search up periodic table, just get your mass, or it should be in any of your standard textbooks. So for aluminum sulfite, I got 294.05 grams, sodium hydroxide 39.98 grams, sodium sulfite I got 126.01 grams. And again, to spark anyone's memory, you just take the individual mass of each atom and multiply that by the number of times that it's in the molecule. That's basically what you see here. Feel free to pause it if you need to take any notes or try to understand what that's doing. The next step is to determine which of the reactants is what we call the limiting reactant. So if you take aluminum sulfite, the problem gives you 389.4 grams. And you want to convert that into moles. And in order to do that, you're going to use the molar mass calculated in step 2. So here we have 294.05 grams per mole of aluminum sulfite. And if you multiply that out, you would get 1.32 moles of aluminum sulfite. Then you want to check how much of the sodium hydroxide would be consumed if the reaction fully used up the aluminum sulfite. So in order to do that, you need something, basically the ratio of sodium hydroxide to aluminum sulfite. And that's just given from this balanced equation. You need 1 aluminum sulfite per 6 sodium hydroxide, and you yield 3 sodium sulfite and 2 aluminum hydroxide, theoretically. So once you multiply that out, this ratio, you get 7.92 moles of sodium hydroxide, which would be used if it follows the equation perfectly. You're going to do the similar thing to sodium hydroxide. You're given the mass of sodium hydroxide and you convert that to moles of sodium hydroxide. Once you have your moles, you want to multiply that by the ratio given by the equation. Take careful note of how your ratio is formatted. Above we have 6 moles over 1 mole, and for this part is 1 mole per 6 mole. So just make sure you have that correct. So 10.64 moles would equal 10.64 moles of sodium hydroxide would require 1.77 moles of aluminum sulfite if it's fully consumed. So in order to figure out which one is the limiting, you can kind of look at it. If you need to use all of the sodium hydroxide, you would need 1.77 moles. But above, we determined that we only have 1.32 moles of aluminum sulfite. So therefore, you can conclude that the aluminum sulfite is the limiting reactant. After that, we're going to use the number of moles that we calculated for aluminum sulfite because it is the limiting reactant. And we're going to assume that all of the aluminum sulfite is consumed, and we need to determine how much the maximum mass, also known as the theoretical yield of the equation, how much of that mass would be sodium sulfite. So you multiply your 1.32 moles times your ratio given by the balanced equation, and you multiply that by the molar mass of the sodium sulfite. So here we have 1.32 times 3 divided by 1 times 126.01 divided by 1. And you're going to get 499 grams of sodium sulfite. So that would be your theoretical yield. Also the maximum mass of sodium sulfite that you would get from this equation, and the given mass of reactants. The second part of the problem asks you to determine the percent yield for the reaction. So what it does give you is the actual mass of sodium sulfite that was produced. And now what happens when you're actually mixing these substances in the lab is that you won't always get your theoretical yield, and in fact, more than likely you'll get less than what your theoretical yield is. So to find what the percent yield is, the equation for that is the actual yield divided by the theoretical yield times 100%. So if we only get 212.4 grams and the theoretical is 499, you divide them, you multiply by 100, you get 42.57% for your percent yield. And that would be the answer to part B. So hopefully that helped you. If you need further assistance, please feel free to leave a comment or send me a message. Thanks. Bye.